Hello, my name is Albert Liu. I'm the product manager for Service Provider Security Solutions at Juniper Networks. Today I'm going to be speaking about security everywhere, how Juniper's mobile cloud architecture secures everything. We're going to cover challenges and trends, use cases and solutions, products and services, some proof points from outside sources in the industry, and Juniper's mobile cloud architecture. First, let's talk about challenges and trends. And what's really happening here is this massive challenge in the rapid growth in security threat and exposure. Let's begin with threat sophistication. The really scary thing about threat sophistication is not necessarily that threats are getting more sophisticated. They certainly are. Threats are becoming harder to find. There are more and more zero-day attacks. Threats are now holding people and organizations ransom. They're demanding money in order to let go of the networks. But again, that's not the scary part. The scary part is that the actors who are coming up with sophisticated threats are realizing that why should they have all the fun for themselves? They could involve themselves in profit-sharing models and contact nation states and other actors who would be really interested in mounting directed attacks towards other nation states and organizations and just renting out very, very sophisticated threats in a profit-sharing model. So not only do we have to be worried about the sophistication of threats and how much more complex they're getting, but also the fact that there is this new business model with ransomware in which those who are most interested in carrying out the attacks don't actually have to know anything about how to build the attacks. Another interesting aspect of security is the introduction of the cloud. Before the cloud, organizations would stand up applications in their networks, and they would know about the resources that were physically there and make plans about how to actually protect those resources. It was pretty straightforward. You'd have lots of time to do it. You'd be able to test it in your nice little sandbox, and then you'd be able to roll it out to the world. Well, with the cloud, that all changes because now we have the ability to create software-defined networks and applications that happen on demand. And on demand means not only instantaneously, but also applications that scale up and down. Trying to plan for the security of these dynamically involved resources becomes very, very challenging. It's very, very difficult to try to create a security posture like you had in the physical world with the introduction of the cloud. And needless to say, the cloud also, on the bad side of things, provides attackers with many, many more resources that they can gather together to mount attacks. And then the third trend that we're looking at is an explosion in the variety of infrastructure and a massive expansion in the threat surface of that infrastructure. So cloud, for instance, means that we see hybrid cloud deployments where we have a marriage of both private clouds and public clouds. Trying to understand how to protect that kind of environment is definitely a mind-bending task. We are seeing devices come in from everywhere. So the old mantra of let's protect the perimeter becomes very challenging when your perimeter can be breached simply by someone bringing a smartphone or, frankly, any device into the network. And then we're also seeing that there is data that's being stored everywhere about everything that's going on, and many, many more devices, several orders of magnitudes of devices being introduced into the network with the Internet of Things. And I'll leave you with a short thought about, well, what do we need to be worried about with the Internet of Things? And this is what keeps me up at night, is that with Internet of Things, one particular vertical is connected vehicles. And connected vehicles you might think of as self-driving cars, but what about our self-driving infrastructure? What about the truck that Uber recently commandeered that self-drove beer from the distillery over to the place where the beer was sold, restaurant or grocery store? Now, if you take that to its logical conclusion, that means that our entire food supply chain can be automatically driven without any human intervention. If we pervert that, it means that someone could hold an entire metro area hostage and drive the food supply chain, for instance, straight off into the water. That's what we need to be thinking about when we think about challenges and trends, the ability to rent out the attack to hold an entire metro area hostage by taking over connected vehicles. So what do we do about that? Well, one answer is a software-defined secure network. It consists of three pillars. One is policy, other is detection, and the third is an enforcement. And how do these things work together? Well, first of all, we need to be able to have accurate detection of the types of threats that are happening. And this is really, accuracy of detection is really, really important, because with the cloud, we need to be able to automate what we're going to do with respect to enforcement. Unlike in prior worlds where we could kind of look at attacks at our own leisure, now as soon as you detect an attack, you have to have a high confidence level that you can actually automate the enforcement. And part of that automation involves how are we going to decide what to do? And with that respect, we need to think about a dynamic and adaptive policy engine. That policy engine needs to allow administrators to describe, well, here are the resources we have in the network. If we see a report on a particular type of threat, we want to be able to enforce a policy that says, for instance, we're going to quarantine that threat with all the resources we have available in our network, not just with security devices. And in this software-defined secure network, we also need to think about how there is an open ecosystem that needs to happen here. In other words, it can be Juniper and third-party cloud-based threat defense. It can be Juniper and third-party detection and enforcement. Juniper needs to have a way in which we can communicate what's happening with our policy engine to third parties. So it's really an open framework. Because if you think about the thousands and thousands of security startups that are being funded by venture capitalists, they're all focused on very specific problems. But really what they're doing is primarily in the area of threat detection. They don't really do a whole lot in terms of enforcement because, well, that's kind of someone else's problem. So being able to plug in this really innovative and very focused thinking about specific security problems is really key. So that's why software-defined secure networks must be, by definition, an open framework and not a closed framework. When we think about enforcement of SDSN, we're talking about a granularity of control, which previously was thought about as perimeter security, and where we said, well, the outside world, the big bad internet, is untrusted. If you originate traffic from the trusted internal part of your network, things are okay. The outside world, and as long as we know that we had originated it from the inside and we don't see anything bad coming from the outside from traffic that started on the inside, you're good. And that led to a certain way of thinking. However, that way of thinking is very outmoded because we don't really know what's inside our network. It really can't be trusted. There are devices that are coming in that the owners may not even know they really have. They may have Wi-Fi connected or Bluetooth connected devices that are potential threat introduction vectors that they just don't even know are threats to the network. IT can't be bothered to understand what all of these different threats to the network are as well. In fact, threats can come in as software builds into application servers. So inherently, the internal part of the network cannot be trusted. We must look at everything in the network, both the outside and the inside, as being untrusted. And we need to look at a way to secure the network and be able to, and by looking at the entire network, we can block such threats as lateral threat propagation, whereas in the perimeter security model, things could go crazy inside the network. Having lots of visibility into the network is part of what's necessary in order to make it secure. In the past, network configuration and security were related based upon the architecture of the network. So you would have a firewall, or you'd have access control lists, or you'd have SDSN SDN service chains, and those would all be related to the specific physical or virtual infrastructure in your network. And you'd be talking about IP addresses, MAC addresses, protocols, port numbers, and you would have to try to organize your applications and business assets up to how your network was actually constructed. This was kind of hard to do, especially in very dynamic moving environments as we move to public and private clouds. Trying to understand all this and the overlay and underlays and trying to describe what you want to have happen from a security standpoint becomes very, very difficult. It's difficult to describe. It's difficult to maintain compliance. It's difficult to keep up with. And as a result, we think that the right way to think about this is to change the model entirely and talk about something what we call user intent policy. And user intent policy is describing what interactions you expect users, devices, applications, sites, metadata to have with each other. And the ability to describe the resources you have, how their traffic flows, what you want to have happen once these resources may be detected to be under attack, that now gives you a much better way to describe how you want to react to security. It allows you to have automation in terms of your reaction, and it allows compliance because you actually have understanding about what's happening inside your network. And then when we take a look at threat management, previously the workflow was extremely manual. I've talked to IT administrators who have said that, okay, they have a third-party incident detection system, and then once that incident detection system or service alerts them to the fact there might be an incident, they have to then call up people, and those people have to kind of figure out what's going on. And then once they've assessed what's going on, what the threat is, then they might actually talk to someone else who would be able to think about this. And the process, if you look at public attacks that have happened, just take a look at how long it took to resolve the recent East Coast and the U.S. internet outage that was a result of an attack against a DNS provider. It took almost a whole day for that to all get sorted out. You can just imagine the blood pressure going up there. And it's very, very imperfect. And it also means that if you don't actually detect incidents, then people really can't do any response. It doesn't work very well. What really needs to happen here is management of threats needs to be completely automated. There needs to be a way to take in third-party feeds, to take in information about command and control, about GeoIP, to create your own feeds, to take information from, for instance, one of Juniper's partners is IBM, and they have Watson, which is an artificial intelligence model or engine, and Watson can use information that's in a SIM and inform our policy controller and engine about threats. Being able to then take all that information and to auto-mitigate potential threats is really the key towards effective threat management, because what it does is it reacts much more quickly, it stops lateral propagation, and it really allows the organization to continue in the face of a security threat as opposed to be completely paralyzed while the manual process is happening. So one way to look at the expression of SDSN is within a secure Internet of Things service fabric. And when we think about this, this means that SDSN can be applied in many places. Starting on the left, we can do detection as well as policy description and enforcement in an IoT gateway. Some of this same capability can happen the mobile edge computing part of the network, maybe a little bit deeper into the network. It can be integrated in with the evolving distributed user and control plane model of the packet core. We could also think about putting cloud CPE capability and the same automatic detection policy and enforcement further towards the core of the network. And then, of course, we can use SDSN as a way to defend IoT applications and services deeper in the network. So an IoT service itself would be described through a variety of network functions, physical and logical, which happen from the very edge of the network on the left to the very core of the network on the right, and this can all be protected and coordinated with SDSN. If we now jump, changing subjects a little bit, to use cases on securing mobile network infrastructure, there's three particular insertion points where Juniper plays. The first is LTE Security Gateway. This is a product which allows authentication of base stations to the Evolve packet core and vice versa. And once that authentication has been established, secure backhaul can take place between the eNode B or base station and the security gateway, and then brought safely into the Evolve packet core. Another insertion point for security is at the GI or SGI interface north of the Evolve packet core. And typically, these GI firewalls and service delivery gateways are used to perform a couple functions. The first is to provide protection of the service provider infrastructure, i.e. the EPC, from outside attacks from the internet. To perform CGNAT, either IPv4 or IPv6 to prevent address exhaustion. And it also can be used to deliver value-added services like UTM, application ID, quality of service capability, perhaps enterprise firewalling and security services. And then the third insertion point is what we call roaming firewall, sometimes also known as a GP or S8 firewall. And this really describes the demarcation of the end of a service provider's network where it connects to another service provider's network. And what's happening here is a bunch of fix-ups and protocol controls so that one service provider doesn't need to worry about the state of traffic coming in from another service provider in the case of roaming traffic. And it also means that service providers don't have to have complete agreement in terms of the formatting of this traffic, the roaming traffic. And roaming traffic now is expanding. It's beyond just data roaming. We're also seeing voice over LTE, which is coming across as data traffic. And the roaming firewall can provide controls on both 3GPP as well as SCTP transport protocol, which is used to transport some of the control traffic on roaming, such as DIAN. We now go to Juniper's security gateway and GI firewall offerings. We can see that we have a whole variety of offerings that share a common set of routing and security capabilities and perform this at unprecedented scale. So on the left, we have the GSRX, which can scale out with Contrail, and it is a virtual offering, and Contrail allows us to scale out multiple of GSRX to look at like a single larger logical security gateway or GI firewall. And then moving on to the right, we have MX104, which can be used as a security gateway, typically in a distributed security gateway application for securing the X2 interface between eNode Bs or base stations. We have our newly announced SRX 4100 and 4200 products. And then we also have our SRX 5400, 5600, and 5800 set of firewalls, which all share common hardware. They just come in different sizes. And they have their MX counterparts, the MX 240, 480, and 960. It may appear that they are different pieces of hardware. I think they're slightly different photographs of the different colors we use, but the actual hardware between these platforms is exactly the same. What we are doing in the 2017 timeframe and 2018 timeframe is making the migration so that we have the exact same security capabilities. In other words, when you are operating an MX or an SRX platform as a security gateway or GI firewall, you'll have the same set of functionality for both the IPsec VPN as well as GI firewall capability between MX and SRX products. That's part of our Unified Services Framework effort. And as you can see, going way over to the right, we are expecting within the next year or so that the SRX 5800 and MX 960 platforms will be supporting north of 1 terabit per second of firewall and close to 400 gigabits per second of IPsec, both with IMIX traffic profiles, and supporting necessary for security gateway IPsec tunnel establishment rate, and for GI firewall, such an establishment rate that you would associate with GI firewall or security gateway that has that type of throughput. So now we're going to take a slightly closer look at how we would instantiate Juniper's security offerings in a mobile edge computing environment. So looking at the mobile hub site, which is really where we think MEC typically plays, we could have two potential offerings here. One is the MX104 as a hardened security gateway running our SRX security gateway software because it's using USF. And the other is our NFX250 offering, which allows us to combine third-party applications together with Juniper security offerings. So in this particular case, the NFX250 could support a MEC server, which would allow filtering of the S1U traffic and to remove the GTP. There could be a network performance application, an IoT application that would have IoT middleware, for instance, or maybe IoT analytics. And then on top of that, we could have our VSRX acting as an IoT firewall. And then in the cloud, the telco cloud, we would have the matching parts of this. We'd have the application server part of the network performance application, the IoT application, and the VSRX also could be used to perform security for those application servers. And all of this would be organized by Contrail Service Orchestrator. We would use the SDSN policy enforcer in order to perform automatic detection and mitigation of threats. And there could be information about detection coming from both SkyATP, which is Juniper's cloud-based threat detection system, as well as JSA, which is the Juniper SIM. And there could be third-party feeds coming in on command and control and GeoIP information into SkyATP, which then gets filtered down to the SDSN policy enforcer. So there is the policy enforcer detection and enforcement that can happen both at the mobile hub site as well as at the telco cloud. Switching around a little bit here, we have a use case for distributed security gateway. And the drivers for this are really LTE advanced and going forwards. There are new technologies like coordinated multipoint and enhanced intercell interference coordination, which require that there is intercell communication that happens with a very short latency of less than 5 milliseconds. In order to do that, 3GPP has described this X2 interface between the base stations, and in order to have this, our first instantiation of the distributed security gateway uses the MX104 so that it can provide IPsec security tunnels between base stations that are happening more at the edge of the network. Going forward, we expect to be able to deploy our virtual SRX in a hardened platform, which could also operate as a distributed security gateway. Now, it doesn't remove the need for a core security gateway, so you'll see over on the right side, SRX 5800 is still performing IPsec termination for the main S1U traffic. And then to begin our wrap-up about our security offerings, we also, in addition to a whole range of security portfolios for protecting the mobile cloud, we have the ability to offer services where we can plan, build, and operate these solutions for our customers through our Juniper professional services offerings. We can do assessments, deployments, we are supporting custom engagements, and customer onboarding. I was recently talking with one of our account teams about how we can even train our customers so that they can become fully self-sufficient to operate Juniper solutions. And we have multiple proof points for our security offering. We've had a lot of very, very positive feedback about our SDSN framework. Customers realize that the way that they have been thinking about security really hasn't worked very well because it's very, very ineffective and slow moving. We're making the move in the right direction to do that. If you look on the lower left-hand corner, you'll see that we also are innovating both in terms of a containerized SRX, that's what you see as CSRX, which will not only allow leverage for securing east-west traffic, but also is a very, very agile offering that can be matched very closely to dynamic applications. And then our VSRX offering, the virtual SRX, has the ability going forward to deliver very, very high levels of performance because it has the ability to support multiple cores, and of course we can scale even that out with Contrail. And as our CTO liked to say, the security landscape is definitely evolving, and one of the key parts of SDSN is not only Juniper's ability to meet that evolution of the threats, but also our ability to have a framework in which we can plug in third parties which can help us detect and defend against these attacks. So in summary here, the proof points, we have a very comprehensive, interoperable, integrated, high performance, and open framework, and that's the way that we're thinking about security. Our Security Everywhere is one of 5 solutions within Juniper's mobile cloud architecture, and those solutions include automated control and orchestration, disaggregation and virtualization, distributed data centers, and integrated packet, optical, and timing solutions. I encourage you to learn more about these other solutions from the many resources that Juniper has available to describe these solutions for you. Thank you very much for your time, and I encourage you again to learn more not just about Juniper's Security Everywhere, but about all of Juniper's mobile cloud